Now, a couple of wee things that we're looking at today, and this is basically just a wee introduction to a wave. Okay, so there's a couple of wee keywords that you need to know, right? So the waves that we've been looking at, this could be a sine wave, it actually has an amplitude, and that's basically how high the wave goes. So it starts off, if it's just a normal sine wave, starts off at 0 and it goes up to 1. So we can actually say the amplitude, help if I could spell it, equals 1. Right, so this wave is just the wave of sine x. Now, the length of the wave, okay, we can call the period. So that's from here to here. That's known as a period. Now, obviously, this is just a wee snippet of the wave, so it can continue just going on and on. Okay, now it's not the best drawing, but that's essentially saying that the period is just the part of the weight that after that would keep on repeating itself, so that'll keep on repeating itself. So it's the part of the weight that's got no repetition in it, and that's known as a period. Okay, now we've been looking at it. It's gone from 0 degrees to 360, so that's a period. Okay, so that's period of 360 degrees. Now, if I was to go File, New, and then I showed you the wee spreadsheet, so this is what you're working on here, right? So you got a set of data, you then had to fill it in. So sine x, and x just takes 30, 60, 90, all the way up to 360, and then 2 sine x, and then 3 sine x. And what you had to then do is essentially just match up the data with the graph. And you would have found if it's just sine x, it goes up to 1 and to -1, so that actually means that the amplitude is just 1. Okay, so if we just said, and I'll try and get this written neater, if we just say sine x, we can say amplitude is 1. If we then go back to it, if we look at the sine 2x, we can see it goes up to 2. So that's amplitude is 2, right? So if we then can say, just say 2 sine x, we can say amplitude you probably see the wee theme. And then we've got 3 sine x. So if we look at 3 sine x, amplitude is 3. Okay, from 0 to 3 and 0 to -3. Right. So we go 3 sine x. That's your amplitude is 3. So hopefully you'll be able to see from that is the number in front of the sine x basically gives the amplitude. So if it's 4 sine x, amplitude's 4. If it's 2.5 sine x, amplitude is 2.5. Okay, a half sine x, amplitude is a half, right? So that's your initial one, amplitude, because that's just a covenant sine 1 times sine, and any number in front, oops, that gives you the amplitude. So that was the aim of that. Now we've discovered that the number in front is just the amplitude of the wave. We then did a wee task in which you get given these functions. So it's sine x, that actually means sine x over 2. So that was sine x divided by 2. Okay, now when we look at that, and then we look at sine 2x, what we've got is a blue wave is sine x, so that's still got the period of 360. So if I just wrote that down, so if we go back to sine x, we've got the period of one wave is 360 degrees. Now if I go back to it, and if you look at sine 2x, what you'll find is that's in green, and you actually find that it's repeating itself twice within 360. And what you actually will discover, remember, a period is just the part of the wave that has not repeated itself yet. So we've actually got two waves within this 360. Okay, so if you have sine 2x, we actually see that there's two waves in the 360 degrees. Okay, so to actually work out the period of that graph, you would just say 360 divided by 2 equals 180. Okay, so that confirms from us looking at it that it was indeed 180, but you might not have the opportunity to graph it all the time. So this is the quick way of doing it. So if I was actually just to say, I'll just scroll down here, if I was just to then say sine 4x, if I put this in the spreadsheet, you would end up getting 4 waves in 360, and to actually work out the actual period, right, that's a period, you would just say 360 divided by 4, and that equals, that'll be 90 degrees. So the graph of the wave has got a period of 90. Now if we went back to that one, what you would actually have is you would essentially say 360 divide by a half, and that actually means 2 times 360. That equals 720, and what that means is the period of this graph is actually 720. So if I was to just pop back and show you, you would see that this is the half x. You would see that there's only essentially half of the initial sine wave is managed to cover 360, so that's why we double it. Okay, so just to say that that part of the function actually just tells you how many, or the size of the period, as it were.